learning path 3. So I hope you got a clarity on how to use storage account blob storage or blob service. Now it's time for us to move to the next part, that is learning path 4, develop solutions that use Azure Cosmos DB. So we will be working on that. It has two modules that we will going to cover here. One is explore Azure Cosmos DB and work with Azure Cosmos DB. So first is the explanation about Cosmos DB, and second is how to programmatically work with it. So Cosmos DB. Cosmos DB basically is used to work with the NoSQL databases. So we will understand in this the benefits that is provided by Cosmos DB. We'll describe the elements in the Cosmos DB account and how they are organized. We will see the different consistency levels. What is consistency levels? Right. What consistency levels are there and how to choose correct one for your project. Explore the APIs which are supported in Cosmos DB and choose an appropriate API for your solution. And then we'll describe how the request unit impact the cost. And last, how to create a Cosmos DB resource by using a portal. So let's jump into it. So what is the Cosmos DB? Right. So getting into this, I will just show you one explanation with a Word document that I've created to simplify the things. It will make the things easy for you. Then I'll come back to the slides because I'll talk about the key capabilities of the Cosmos DB here. So I have designed some diagrams for you, which will help you to understand this topic in much better way. So Azure Cosmos DB is a global distributed database service that is designed to provide. Now, these are the key benefits: low latency, elastic scalability of throughput, well-defined semantic for data consistency, and high availability. So we will understand that how it is globally distributed database service. And once you understand that, then you will understand that how it is going to provide low latency, right, high availability, and then we'll talk about the consistency levels as well. So usually, if I talk about the storage account, what we just discussed, the maximum replication was geo-redundant. If means that if I have created a storage account in East US and I have choose geo-redundant, so its copy will be available in the West US, in the paired region. So that if my main region will crash, second region is there to provide the, backup, and my users can get the data from there. But if I talk about the people who are not in East US or West US, if they want to read the data from that storage account, maybe they're from India, maybe they're from Africa, maybe they are from Russia, right? So they have to send the request to East US to get the data. So for them, there is a latency, right? So it will take time for them to read the data, right? So we want a way by which we can simplify this. So for that, Cosmos DB comes into the picture. So let's say I have created a website. So I have created a website and I have created 3 instances of that website, which is running in 3 different regions. Let's say East US, India, and Africa. So this website is hosted in 3 different regions. And then I configure the traffic manager so that if people are accessing it from internet, no matter from which part of the globe, it will go to the traffic manager and traffic manager will forward the request to the nearest region. It can be East US region, Indian region, or African region. Now, within that website, I have written a data access logic so that you can access the data which is stored in my Cosmos DB. So initially, if my data is only in Cosmos DB1, only one instance is there, right? I don't have other instances. So if I don't have other instances, let's just delete them. So it means that all the websites, no matter which instance I'm talking about, right, they will send a request to the single instance of the Cosmos DB. So all the requests will go to the single database. So it means that there is a latency. The people who are accessing the website from Indian and African region will take time to get the data because the data has to be read from the East US region. And if something goes wrong to the database, it will crash your application. So we go with the Cosmos DB. Cosmos DB says that I will allow you to replicate that database in different regions. You are not bound to choose only paired region. You can create the instance of that Cosmos DB in multiple regions. Right. So there is no limit. You can create it in 100 regions. Just giving an example, or 20 regions. So it will create that. Now, my application says that whenever I need to talk to the database, I have a same URL. So your request will go to Azure. Azure will find the nearest Cosmos DB instance with the same URL and then serve your request from there. So people who are accessing it from India, Africa, or East US, they will get the data with the same latency as the people from US. And the best part is that all the instances are synchronized with each other. If you make changes in one, the data will be synchronized to other so that you can get the latest information. And if due to any reason, if one server fails, right, then automatically the request will be served from the nearest Cosmos DB. And in the meanwhile, the server will be reconstructed by Azure. So that is why it is called globally distributed data service. And because of this, it is providing a low latency and highly availability. Because high available, if suppose this database fails due to any reason, so request will be served from the nearest database. Automatically, request will be redirected to nearest database because the URL is the same for all the database, and Azure is taking care of that how to find the nearest database. So it is highly available. So that's the difference between the storage account and the Cosmos DB. Another difference, because in Cosmos DB we are not restricted to deploy my resources only to 2 regions. No, we can deploy it to n number of regions, and that too with a single click. We just say that, hey, I need a instance in this region, and Azure will automatically create a infrastructure for that, deploy your resources, and provide the high availability and low latency. Now, the next thing that you need to understand, that what are the benefits that you will get. So it will provide unlimited elastic read and write scalability. No matter from which part of the globe you are reading or writing, it will give you 99.999% of agreement, right, of high availability. And it guarantees that all read and writes are performed within less than 10 milliseconds. So single digit of latency, they guarantee that. That is the benefit of it. Now, people say that I am already working with NoSQL databases like MongoDB. I'm working with Cosmos DB. I'm sorry, MongoDB. I'm working with Cassandra. I'm working with the Gremlin. So I want to take the benefit of Cosmos DB because if I'm working with the MongoDB, Cassandra, Gremlin, I'm not getting all the benefits that Cosmos DB provide, right? Like global replication or 5 level of consistency, which we will be talking about. I want to take all the benefits. So I need to migrate our resources from MongoDB to Cosmos DB, Cassandra to Cosmos DB, Gremlin to Cosmos DB. So is it possible? Yes, it is possible. Because Cosmos DB is a wrapper around these 6 APIs, right? So we have one more. I will be showing you that, right? So we have now 6 APIs which are available, which are available under the Cosmos DB. So whenever you are working with Cosmos DB, you have to choose one of the API to store your data. It can be SQL, it can be table, it can be Cosmos DB with MongoDB, Cassandra, Gremlin, right? PostgreSQL is the 6th one, right? 6th one is PostgreSQL. Cosmos DB with PostgreSQL. Right. So you can work with that. So this is a 6th one. Now you can easily migrate your data because structure of these services are same. So you just migrate your data and your application says that I just need to change the connection string. Only that change. And then you will take all the benefits of Cosmos DB. So these are the 6 APIs which are provided. Now, you need to understand another important thing which we discussed in the definition of it, right? That is, it will provide well-defined semantic of data consistency. So if I have data available in different servers and it will going to replicate the data, so how to read the data, right? So in most of the databases like SQL, Oracle, we have only two level of consistency. One is strong consistency, another is eventual consistency. But in case of Cosmos DB, we are providing you 5 different consistency levels. Strong and eventual is there, but it will also provide it bounded staleness, session, and consistent prefix. So this is an extra benefit that you will be getting it when you are moving towards Cosmos DB. Now, what are these consistency levels? That's something that I would like to talk about it. So eventual, I'll start with eventual first, and then strong, and then others. Because when we go to the slides, I will just flick on the slides because whatever is on the slide, I'm just explaining it to you here. Because pictorial represent will make more impact, right? So eventual, let's take an example. I have only 2 replicas. One is in East US, another is in India, right? So I have already added A, and A is already there into the Indian server. It is replicated. Now at 10 a.m., client has added B and then C into the East US server. Now, hypothetically, it will not take that much time. Hypothetically, think it will take 2 minutes to synchronize the data to the Indian server. Means another instance of Cosmos DB. Now, if any read request comes from client 1, and at the same time, client 2 is also sending a request, but they are on different servers. So client 2 is sending a request to US server, and client 3 is sending a request to Indian server at 10:01 at 10:01 at the same time. So what data they will get? So if you have configured eventual consistency, means whatever data is there on that server will be given to the customer. So the customer 2 who is submitting a request to East US server will see the latest data like C. And if you talk about the person who is submitting a request, submitted a request to Indian server, he will be able to see the value B. Just let me change it here, B, right? Or let's say it is C here, so he will get C. Now, he will get C. So this is good, but it might be possible that it is B, so this person will get B at that particular time. So there is no consistency, right? So this result is different from this result, right? As another important thing about eventual consistency, when you are replicating the data, right, when you're synchronizing the data, the ordering is not guaranteed. Means on the main server, you have added A, then B, then C. It might be possible that it will synchronize A, C, B. Ordering is not guaranteed, right, in eventual. And when user reads the data, it will get the data, whatever is on that server, right? Because I just want that customer should see the data. We are not worried about a consistent data, right? So we can go with this technique, right? So that is an example like news. If you talk about news, so different channels are there, right? So they just want to show you the news at the same time. They're not bothered about in which order they are showing the news. So when certain many events are happening in country, so they get the updates, but not in the same order, right? So each channel will show the news which have arrived to them at a particular time. So that is a good example of eventual consistency. Now, if you talk about the strong consistency, I'm just going with the strong consistency, then I'll explain other. So strong consistency is explained here. So strong consistency means I'm only going to show that content which is synchronized to all the servers. Now, when you look into this, sorry, just give me a minute. Right. Okay. So when you look into this image, right? So you can see that I have a primary server and I have 2 secondary servers, S1 and S2, means I have 3 replica of my database. And I have two clients, C2 and C1. Now at 9 a.m., you have added value A to a primary server, and that 9 a.m., and then it is synchronized to server 1 and server 2. And now at 10 a.m., you added value B on the primary server, and at 10 a.m., it goes to the server 1 and say, hey, this is the new value. And server 1 has acknowledged back at 10:15, yes, I get the updates. And server 2 will send the acknowledgement about the value at 10:30 a.m. Means at 10:30 a.m., server 2 says that I got the updates, right? So now when client 1 and client 2 read the request, no matter from which server. So let's say client 2 has submitted a read request at 10:10 from server 2. So what result will get? It will get value A. So you'll say that yes, it is value A because he didn't acknowledge it. He doesn't have the value B. Okay, fine. But what about customer 1 who is reading the request as 10:20 from server 1? He's still getting a value A, but he has acknowledged that I got value B at 10:15. Why he is getting that? Even on the primary server, when you are reading the data at 10:15, you are still getting A. You're not getting B. The primary server has value B at 10. Why? Because of the strong consistency. Strong consistency says that unless and until the primary server don't get acknowledgement from all the servers, till the moment you have to give the last synchronized data. So at 10:30, it get acknowledgement from all the servers, right? And then at 10:40, it sends the information back to all servers. Yes, I got your confirmation. Now after 10:40, if any request comes to any server, they will get the value B, right? So that is a strong consistency. Means you will not going to see the data which is not yet been acknowledged at all the servers, because it might be possible that due to any reason any server will crash or they will not get the update, so you have to roll back the things. So you do not want to show the dirty data to the customers. So dirty data is the data which is not synchronized to all the servers. So in that case, strong consistency is there. Like banking system, you never want to show the bank balance update for the transactions which are still in progress. You will show the old balance. And once the transaction gets completed, then you'll show the latest balance. Because if transaction cancelled, so still the content will money will be rolled back and old content is there. So that is what strong consistency is all about. Then we have other consistency levels in between, right? And what are those consistency levels? So we have another consistency level that is called bounded staleness. It is quite similar to the strong consistency, but here we are setting that whenever request will come, I don't want to show the current synchronized data. I want to show little stale data. Let's take an example. I have set the staleness to 1 hour 30 minutes. Means if any request will come, it will only give you the last synchronized data, which is synchronized 1 hour 30 minutes before. So let's say at 11 a.m., I have added value A on the primary server, and it gets updated on the secondary server as well at the same time. Right. So value A is available on all the servers at 11 a.m. Now at 12 a.m., you have added B, which is also get updated on secondary server. But at 12:30, right, 12:30, you submitted a request to secondary server or maybe to the primary server. So what data you will get? You will not get the latest update, value B, though it is synchronized. You will always get value A because you say that I don't want to show the latest synchronized data. I want to show the data which is synchronized 1 hour 30 minutes before. So I will always go, or I will show the data which is updated 1 hour 30 minutes before, always. So I will get that, right? So I'll get that. Even at 12:45, I will do that. But if I send a request at 1:30, 1:30, so 1:30, if you calculate 1 hour 30 minutes before, it is 12. So at 12 hour, we have value B, which is synchronized. So after 1:30, whenever you send a request, you will get value B. So that is a staleness in the data, because it might be possible that after uploading the data, I don't want to make it visible for the next 130 minutes. Why? Because I want to do some manipulations on that. So that's why bounded staleness is used. Similarly, we have another consistency level that we will be talking about is eventual, I told you. Now, consistent prefix. So consistent prefix is quite similar to eventual, right? Means customer will see whatever data they have on that server at that time. But the only difference is that when synchronization happens, it will be in the same sequence. Like if you have added A first in the primary, then B, then C, then D. So A will be synchronized, then B will be synchronized, then C will be synchronized, then D will be synchronized. But in case of eventual, this ordering is not guaranteed. It might be possible that you have added A, B, C, D in the primary. So when it is synchronized, it will be B, C, A, D in any order. Ordering is not guaranteed. But if you want to maintain the ordering, right, then you can go with a consistent prefix. But yes, when user submits a request, that user will see whatever data you have on that server at that time. That is consistent prefix. Like Facebook, whenever you are accessing your Facebook account from Indian server and another person is viewing it in US server. So let's say you uploaded a photograph, people are commenting on it. So you want to see the comments, right? But in the same order. Let's say you logged in into Indian server, your account is in Indian server, so 10 people have commented it. But when you go to US server and you watch your post, but only 5 comments are synchronized, but you want to see in the same sequence. So you go with a consistent prefix in that case. So that is a consistent prefix. And last but not the least, we have sessions, which is a default option available. Session is a default option. So I'm not going to show you session here. I will draw that session for you because it is little tricky. So I'll take the open board because session is something interesting to know with, and it is a default one. It is a combination of strong consistency and the eventual consistency. Okay, so let's take an example. This is my Cosmos DB instance one in East US, and I have another one in maybe some in African region or Brazil, somewhere in Brazil. I know that the data has to be synchronized, right? So I have A here, and A is already there. Now there is a user one and a user two. So user one has initiated the insert statement. So at 10 o'clock, 10 a.m., he has added B, right, and C. So this server has B and C. Okay. Now it takes hypothetically 2 minutes to synchronize the data. Now, when this user, let's say this user has submitted write request. Now, if the same user submit a read request to this server and this server, right, submitted a read request with the same session, right? So what he will get? This will work with a strong consistency. For this user, strong consistency will be in use. Means this user will see whatever data is synchronized. So in this case, he will get what he will get? He will get A. But when this user 2 submit a read request either to this server or this server, so he will work with the eventual consistency. Eventual means he will get A from this server, and from this server he will get C. Right. Now, if suppose B is synchronized and then B is also synchronized and this user submit a request, he will get B. And user 2 will now get B from this server and C from that server. So this is what session is all about. Session says that the user who has opened the session for inserting the data in one server, and he within the same session, he will try to read the data from any of the instance of Cosmos DB, right? Or a replica of it, he will go with a strong consistency. But if any new user or any other user establishes a connection and he submits a request, so depending on which server the request will go, he will get the data whatever is on that server at that time. So that's why it is called eventual consistency. So that's what we have just covered, the 5 different consistency levels as well. Now, the last but not the least, I will show you the way the things are being organized, right? So I'm just using the example. So structure of Cosmos DB. In the slide, they are just talking about this SQL one, but I'm talking about other as well. So as I told you, Cosmos DB supports six different consistency levels. Postgre is recently added. So SQL API, Cassandra, MongoDB, Gremlin, Airtable, and Postgre. Now, what is the topmost object in the hierarchy? So if you want to work with these APIs, so for SQL API, you have to work with database. The topmost object is database. In Cassandra API, you have to create a key space. If you have used MongoDB, Cosmos DB with MongoDB, the topmost object is database. In Gremlin API, it is database, but there is no such concept in tables. Table API does not have any database concept. Now, within the database, you can have one or more containers in SQL API. In Cassandra API, key space has tables. MongoDB database has called collections. We call collections. In Gremlin, database has graphs. It is again a collection. And we start with table in the table API. Now, containers will store actual data. So it stores the JSON documents. In Cassandra, the table stores the data in the form of rows. Databases in MongoDB, collection stores documents, again JSON documents. And in Gremlin API, graph stores nodes or edges. And table stores items. So this is the hierarchy that we need to follow. So it is just a name difference, but concept is same, that a parent category having more than one child containers or folders having the content inside. So that's something that they are trying to talk about on the slide. Now, if you look here, so as I discussed with you, that Cosmos DB is a global replication service which has the ability to automatically replicate it to different regions as per our specifications, and the data will be synchronized to all the servers automatically. And whenever there is a failover, so either you can handle it manually or Azure will take care of it. It will support varied consistency levels. I told you there are 5 different consistency levels that Cosmos DB support, which is eventual, strong, bounded staleness, consistent prefix, and session. Session is default. I have explained you as well. Low latency, it will give you a guarantee that all read and writes are performed in less than 10 milliseconds. So it gives you the 99% guarantee of that. Elastic scale out. Now it depends upon the workload. If your workload is heavy, right? So you can basically perform maybe 10 to 100 millions of requests per second. You can submit 10 to 100 millions of requests per second to multiple regions, and it will be served. Now, if you have heavy workloads, maybe 10 million requests will be served per second. But if your workload is very simple, like read select star from that table, so you can get maybe 100 millions requests can be served per second. But yes, the number of requests which can be handled per second is in millions. Now, the architecture, as I was talking about, I have shown you the last thing, right? So they're just talking about, sorry, my bad. So they're just talking about this hierarchy, right? Only this one, SQL one. So they say that if you need to work with the SQL API, right? So you need to understand the hierarchy. So first of all, you need to create a Cosmos DB account. Within that, you have to create a database. And this database can have one or more containers, and each container can have the items, means documents, which is a JSON document. The Cosmos DB is the fundamental unit of global distribution and high availability. It will provide all the benefits that I told you, right? Like consistent read and writes, right? Five different of consistency levels, global replication, less than 10 millisecond read and write, you know, read and write latency. That's what they talk about. And whatever API you are working with, it is not only Cosmos DB for SQL. No matter what API it supports, like out of 6, all of them will get the same benefits. But yes, you need to understand the hierarchy of the objects that you need to work with, which I have just explained it to you. Now, this is what I discussed. So first of all, you create a storage account. Within that storage account, you create a parent object like database, key space, right? You define that. And within that, you create a child folders like containers, right? Table or key space, sorry, not key space. You define the containers collection, sorry, and the tables. So you can define the second level database. First of all, database, key space, right? You define that. And within that, you define containers or tables or collection or graphs, depending on what is the parent object, right? Or what type of API you are using. So we define that, and within that, you define the items. Now, if you're using a NoSQL API, now NoSQL API will also provide you the stored procedures, user-defined functions, and triggers, which are written in JavaScript, JavaScript. So you can also work with these capabilities. As you can see, when I'm talking about containers, containers can be collection, container can be table, container can be graph, container can be your uh, you know container has a name container. If you're going with a SQL server, sorry, NoSQL, so database is the parent one and container is the child object. And each object has its own items like documents, rows, node, edge, right? Depend on the type of API you're using. So I told you about the various consistency levels: strong, bounded staleness, session, consistent, prefix, and eventual. So high availability, low latency, and high throughput. If you are moving from strong to eventual, so high availability is there, you will get your data much faster and high throughput. So that's you have to consider. Either you need a low latency or strong consistency. If you need a low latency, eventual is there, but high consistency or strong consistency is not there. So you have to plan it accordingly. So I have already explained it to you what is strong, bounded staleness, session, consistent, prefix, and eventual. You can read this in the book itself, but I have explained you well with the diagram, right? As such. Now choose the right consistency level. So you have to decide which consistency level you want to work with, and it depends upon the type of problem you're solving. I gave you an examples of the problem that you have. Like you can go with the, if you want to work with a Facebook, like simple example where you need to see the comments in the same order. Maybe not all the contents at the same time. I want that whatever contents are synchronized, whatever comments are synchronized, I want to see those comments, right, in the same sequence. So I can go with a consistent prefix, right? Or if I have a requirement that until my transactions get completed, I don't want to see anything. So strong consistency. Or maybe I don't want that when the transaction is still transaction is completed, but I don't want to show the data for the next few seconds or minutes because I'm doing some operation on it. I want to show the old specific version till that time. So I can go with the bounded staleness. So I have to decide what I need. Now, no matter what API we are working with, right, all the capabilities which we discussed are available to them. 5 different consistency levels, global replication, high availability, low latency, everything is available to all of them. The only thing is that we have to choose the right consistency level depending on the problem that we are resolving. Now, supported APIs, as I discussed with you, 6 APIs are supported by Cosmos DB: NoSQL, MongoDB, Cassandra, API for table, Gremlin, and PostgreSQL. So if you are already working with storage account table API, right? Storage account table API. So you can store the NoSQL data there, but you are not getting the capabilities of Cosmos DB, right? You don't get 5 different consistency level. You don't get the multi-region replication. You only replicate in 2 regions. You won't get the capability of the high availability and low latency at that level, like single digit millisecond. So in that case, you can move your content from your SQL, from your storage account table API to the Cosmos DB table API. The structure is same. You can easily migrate your data. And as a developer who is using your storage account table can redirect their request to the Cosmos DB table, right, by just changing the connection string. So there is no need of changing the code. Same API, same SDKs are used. Exactly the same thing with MongoDB, Cassandra, and Gremlin. So whenever, or PostgreSQL. So whenever you are working with these tables or these services to store your data, you can use the migration tools to migrate your data from that particular database into the Cosmos DB APIs. So once the data is migrated, so same tool, same SDKs are being used by the developer. So developer has to do nothing. They just have to update the connection string. And then you can still take the benefit of your Cosmos DB. Now, before I move further, let me just show you that. So here, when I go to my Azure portal, I can click on create resource. And here I will search for Cosmos DB. Cosmos DB. I will go to that Cosmos DB service. Once it is open, I'll show you that. So I'll click on this Azure Cosmos DB, second option, and then I click on create. You can read about that here as well, right? So you click create, and then see, it will give you an option, which API you would like to use. NoSQL, PostgreSQL, Cosmos DB for MongoDB, Apache Gremlin, Cosmos DB for Table API, and Cassandra. I'll go with the NoSQL. You click create. Now, you just have to provide the subscription, the resource group in which you would like to create, the name that you would like to give, right? Cosmos DB training, and in which region you want, East US, right? Then, would you like a dedicated instance or serverless? I say dedicated instance, right? Then, if you want to apply some free discount, you can use that, right? I have already applied it, so in my another account, so I'm not using it. So then global distribution. Now I can enable it here, or I can enable it even after the table is even after this Cosmos DB account is created. Like geo redundancy, multi-region rights, availability zones, I can enable it. Now these options will depend upon the region that you have selected before, because some region does not have availability zone. So you have to plan it accordingly. So don't think that these options are available in all the regions. It depends upon the region to region that which services are there. Let's say Canada Central. Let me try that. It is there. Central India, let's say. Okay. South India. Okay, you can see that in South India, we don't have availability zone. So it is gone, right? So it depends upon the region to region that we are working with. Now, we discussed that. Now we can change it later. How it is accessed from outside world, we can specify that all network, public endpoint, or private endpoint, backup policies, encryption, and then finally, I will click review and create. It will take time to create it. So I have already created one Cosmos DB for you, right? Which I will open it. So once you follow all these things, then a Cosmos DB is created for you. And by default, only one instance is there. So I'm on overview page. So here, if I go to the overview page, right, it will take me to quick start, but I'll go to overview page. Here it is giving me information, right? I have a read and write location is East US only. This is the URL that I would like to access. No matter how many replicas you have, you just use the same URL to work with it. And internally, your request will be forwarded to the nearest instance. But how to make it globally replicated? I have only one. So you can see that I have a replicate data globally option. When I click on it, so I will enable that. Would you like to read and write in multiple regions? Yes. Means I can, when multiple regions are there, so I can read and write on the server which is closer to me, and it will synchronize it behind the scenes. At present, I have in East US region only. Now I know that I am from India, so I would like to create it here. So I can select that Central India. I click on it. Automatically, it will manage the resources for me in South India. I want to bring it in Brazil South. I did that. That's what I did. Would you like to bring it in availability zone? You can do that. And then when you save it, it will automatically create that infrastructure and all the servers will get synchronized with each other. So when you are reading and writing the data in one server, it automatically synchronizes to other servers as well. So that is how easy is to synchronize the data. right? And decide which instance you need. If you don't need any instance, just click on it. It will be removed. So you can control it with ease with single click. Now, consistency level. Let me discard that. Consistency levels. So session is the default consistency level. You can go with a strong consistency. If you choose strong, you can see the graphical images there. It will take a little time and it will show you this. So you can see the order. This is the main. Brown is added all server. Blue. In the same order it is adding. And whatever is synchronized will be served to the customer. If anything is not synchronized, then that information will not be available to the customer. Now, if you go with the eventual, you can see there is no particular order. Brown is added, blue, brown, this. You can say purple is added, then blue. So data is not synchronized in the same order. And when you send a request to the server, so whatever data you have on that server will be given, right? That is eventual. But in case of consistent prefix, the ordering is maintained. The data in which it is order added into the main server, it is synchronized in the same order to that server. And whenever you submit a request, it will give you this data, what is there on that server at that time. So it is eventual, but it is maintaining the order. Similarly, when you click on bounded staleness, you can decide that what is the lag time that you can define, right? So session is default. So you can control this from here. Okay. So that's about the Cosmos DB. Now I use SQL, so I can work with the hierarchy. So you go to the data explorer, right? It is a way by which I can see that how the things are being organized into it. And it depends upon API that what should be the parent container or parent object, what should be the child. So you can see in the data part, I don't have anything. So first of all, you have to create your database, because even if you try to create a new container, it is asking you to choose the database. So first of all, you have to create a database. Within the database, you create a container, and container will have items. So when you are working with the database, you are deciding the maximum read capacity units, right? Throughput unit. So the maximum RU read units per second to the highest RU you want your containers to scale to, right? So whatever read capacity units you are specifying per second here, right? You have to pay for it, and that capacity is shared by all the containers. All the containers will share that information, right? So whenever you're creating a container, you say that it will automatically use this information, or you can say that out of this, how much units a particular container can use, so that it cannot take all the units and don't leave anything for other. So we can define how many read units per second are allocated to the database level, which will be shared by the containers. Now that's the hierarchy. I will be showing you programmatically as well. So we have 10 minutes left with this session. So let's go with that. So I have told you about the request unit. So type of Azure Cosmos DB account created determines the way RU read units are charged. So there are three modes of account creation. Provision throughput means dedicated servers are there. You manage the number of RUs for your apps in hundreds RUs per second increment, 100, 200, 300, 400, and so. Serverless, there is no dedicated environment. So based on the requests that are coming, RUs are consumed and you have to pay for it. Now, if you say provision throughput and you say I want to keep 1,000, so you have to pay for 1,000, whether you are using it or not. But you can go with auto scale. Means I would like to start with 100, maximum is 1,000, and I would like to pay for the auto scale. Means if more resource RUs are required, so it will add 100 more. I'll pay for 200. When more is required, I'll pay for more. And when it is not required, I'll remove it. So for each second, whatever I'm consuming, I will pay for it. So that is how the things work. Now, working with Cosmos DB. So if you want to work with Cosmos DB, so we will identify the classes and methods used to create resources and how to work with programmatically as well. Right. And I told you in NoSQL, you can work with the triggers, functions, stored procedures using JavaScript. So that is also possible. So programmatically, if you want to work with it, so depends. It is not always that you should use the Cosmos client, right? It depends upon what API you're using. If you're working with MongoDB, we have a MongoDB client, right? So for every API, we have a different SDK that you will be working with. At present, this slide is talking about NoSQL API, right? So you are using Cosmos client. So you can just search here on the Google, right? So Cosmos client Azure. So you click on that link. It is talking about here. You can see here. So you can go to the documentation, Cosmos DB, and you will get to know more on that. So you will get to know how to work with this Cosmos DB. Working with Cosmos client, let me just take you to this documentation. And that documentation will have all the APIs. You just have to select. So you can see quick start. So here we have the samples for it, right? How to connect to the Cosmos DB. So you can work with that. So we have a different tutorials available, right? So you can go with the tutorials. You can work with the quick start, how to work with C#, .NET, Java. So you can just search for the right keyword, right? So you'll get that. So I'll just say that, okay, Cosmos client for MongoDB. So when you do that, it will take you to the link where it will tell you how to communicate with MongoDB. This is a good link, right, that you can go with. So when you do that, you will see for a NoSQL, MongoDB, PostgreSQL, which clients you will use. I'm talking about NoSQL. So in the NoSQL, you can go to the quick start and see how to work with it. So when you click on .NET, it will take you to the command, and here I'm using the complete information about it. So programmatically, if you're working with, I just want to show you one thing, that I am using the Cosmos client. Just give me a minute. I'll search for it, Cosmos client. So you can see that I'm using Cosmos client here. So I'm creating a Cosmos client object, right? Similarly, if I'm working with the MongoDB, if you go with the MongoDB, right? So you will work with the MongoDB client object. So you have to go to the quick start of it and play with the MongoDB, right? So you will get a MongoDB client for that. So depending on, so here this slide is about NoSQL. So very first thing is that you need to communicate with the Cosmos client or Cosmos DB, which allows you to work with the Cosmos DB for NoSQL. So I created a Cosmos client and it needs two parameters, endpoint and the key. So endpoint and the key is given here. So whenever you go to your Cosmos DB, you go to the overview part, or it's better to go to the key section here, and you will be able to find the key and the URL that you will be giving it to the customer. So this is the key, right? And this is a URL. These are the two things that you will be providing it to the developer. And with that, it will going to create a client object that knows which Cosmos client it has to work with and how to prove authenticity. Now you can ask client, hey, I want to get a container, which container and where it is available. So you provide the database name, dot, comma, collection name. So it will give you the particular container here. And then you can add the data. Let me talk about what you need to do with the container. You can either delete the container, you can get the data to the container, you can add the data to the container. So now I'm adding the data. So I have a product class. I created an object of it. It has ID, name, group, date, price, quantity. So I want to save it as a JSON file into it. So I can call container dot create item async or absurd item async. I can do anything and pass that object. Now create item async, what it will do, it will create a new item with that particular entry, right? If the item is already there, it will delete, it will do nothing, it will give you an error. But absurd item will update it. It will basically see if an item with that ID is there. If it is, it will delete that item, add a fresh one. If it is not, it will create a new one. So that is the change. These are the two things that you can use to insert your data. Similarly, if you want to get the data, so you have to search the data. There are two ways. Either I want a specific item. So in the previous example, I have added a record with ID, right? And that's what we did. And then in which group? Beverages. So what I can do is I can create a query. I can say, I want to get a data based on ID and a partition key will be beverages. So partition key is to use to organize the similar type of data. So I ask my container, to read item asynchronously. Means I want to read an item on a child thread of product type based on ID and the partition key. So it will submit a select query, select star from that table, select a record from the table where ID is this and partition key is beverage. So I know that this is a record. So this record will be returned to me and I can show that, get that result and use it in my application. But sometimes it requires that I want to get more than one items. I want to get all those items where this item, where the, let's say, diet equals to false or price is less than this. So in that case, I have another way to get that. So I can run a method called get item query iterator on a container. And I'm expecting a product object. Now I'm writing a SQL like query. Select star from products where P is a product. From that product collection, get one product at a time. Check if it's diet equals to false. If it is, put that in iterator. So this query will run on all items one by one, and it will fetch only those items where p.diet is false. And then I can loop it into the iterator and get one item at a time and use it in my application. So that is how we can work with it. Now we also have the capability to work with stored procedures. Now think about the case if every application developer, there are 5 applications, and in every application, I have to write a logic to create an item, to delete an item, to update an item. So that's not good, because if I have to change that logic, I have to change it at every single place. So can we create the functionality in a centralized place? Yes, we can think about stored procedures. So stored procedures is a name given to a method which contain our business logic, and that method reside in my Cosmos DB. So let's say I create a method called create item, which is expecting a document. So I have written a logic that when anyone calls that, he will pass me the document. I will store that document into a container one. So every application can call that stored procedure, pass the document, and then the document will be added. If I need to change logic, I can change it in a centralized place. It will not affect the callers, because callers will still call it with the same name, with the same data, and the logic will change and the logic will update the data in the backend. So customers, client applications are not aware about it. So that is the beauty of it. We can keep our logic at a centralized place, which can be creating a document, updating a document, deleting a document. We can do that. So this is the logic that they have talking about. It is a JavaScript code that we can go with. So you can create a stored procedures into it and play with that. You can also work with the functions. Functions will always return true and false, and it will complete or it can roll back. True means done, false means roll back. Now I can create functions which can take some value and return me the result is true and false. And based on that, I can decide what action need to be performed. Right. So that's what I told you. If I'm creating a stored procedure, and suppose that stored procedure is taking maybe 50 documents at a time, I send a 50 documents to be uploaded, and after 40 documents, if it fails, right? So 40 documents has uploaded, but 10 documents are not. So how to deal with? If I call the same stored procedure again with 50 documents, same 50 documents, so it will be a chaos. So I want that stored procedure can keep an eye on how much task has been completed, and then it will intimate me, so that next time when I start, I'll set the pointer, hey, you have to start it from the 41st document, and it will start uploading it from there. And that concept is called transaction continuation, and developers are responsible for maintaining that pointer where it fails and where it has to resume. Similarly, we have the triggers associated with that. We have pre-triggers, post-triggers, and user-defined functions. Triggers, as I discussed with you, is a self-executable code. Like, I want that when item is about to add, I want to do something. I want that when item is added, I want to do something. When somebody is trying to delete an item, before deleting an item, I want to do something, I can do that. So that logic again resides on the server, right, into the Cosmos DB, in a JSON, in a JavaScript file. So whenever I say I created a trigger that before item is deleted, I want to run that. So I can write a logic to check whether user has appropriate permission to do that or not. If yes, then I will allow him to delete, otherwise I will cancel it. So pre-trigger is the triggers which will execute before the task is completed, and post triggers are the triggers which will get executed once the task is completed. Similarly, what I told you about functions, it will give you true and false. So this is a trigger like validate to do item timestamp. So I want to call this function whenever you try to add an item. So here I'm checking that whatever item you want to add, if it has a timestamp property in the content. If not, I would like to add it, and then I will add that file to the container. So I'm manipulating some data before adding it into the production